Hello everyone, and today we are going to look into chapter 4. So, chapter 4 is all about continuous random variable. So, here also we will have probability distribution function, that is PDF, whereas the random variable is continuous. So, the varying random, the variable which is changing continuously, and also but it is having probability density function, so PDF. So it is denoted with small f of x as mentioned in discrete random variable, but the variable is continuous random variable. We need to check the random variable. There are five conditions for PDF having continuous random variable. One is small f of x is always greater than 0, and when we integrate from minus infinity to plus infinity, the the probability is 1. So if x, this is important, and x is a continuous random variable, and where p of x is equals to a. So whenever a is a constant, so the probability of random variable which is equals to continuous random variable is always equals to 0. What is p of a ranges from a to b, so where x is continuous random variable, like we will calculate uh, probabilities on y-axis with respect to random variable on x-axis between a and b. The area under the curve between a and b is called p of a less than x less than b. Here in continuous random variable, it is same as p of a less than x or a less than or equals to x. Like boundary limits doesn't affect the area of the curve. So these are the five important conditions for PDF having continuous random variable. So let's do a problem. If x is a continuous random variable having PDF small f of x, cx square between 0 to 1, cx 1 to 2, 0 otherwise. We'll calculate, find what is c in that constant, and ranges from 1 by 2 to 3 by 2, and a distribution function which is very important. Like here there is f of x, and we will calculate capital F of x from small f of x. Okay, let's do the first one. What he wants to say, find c. So we know that from the first condition, sorry, second one, minus infinity to plus infinity, f of x dx is equals to 1. So 0 to, I can write it down as from 0 to 1 f of x dx, from 1 to 2 f of x dx, from 2 to infinity f of x dx is equals to 1. From distribution, this is 0 and this is also 0. So what is f of x between 0 to 1? It's a cx square dx. From 1 to 2, and it's cx dx, that is equals to 1. So cx cube by 3 between 0 to 1, and cx square by 2 from 1 to 2. After there integrating, we'll get c1 by 3 plus c4 by 2 minus 1 by 2, that is equals to 1. C is equals to 6 by 11. So second one, p of 1 by 2 x less than 3 by 2. I can like when I draw a number line between minus, so I have 0, 1, 2. I just want from 1 by 2 to 3 by 2. I need this area. I know that from 0 to 1 it's cx square, from 1 to 2 it's cx. Okay, so let's write the function. uh, 1 by 2 to 3 by 2 f of x dx. Okay, so I can write it, break it down to 1 by 2 to 1. So because there are two different functions, from 1 to 3 by 2 f of x dx. So what is function between half in 1 is cx square. So 1 from 1 to 3 by 2, it's cx dx. So it's around cx cube by 3 from 1 by 2 to 1 plus cx square by 2 from 1 to 3 by 2. Substitute c and limits, you'll get c by 11 around 22 by 24. So the value is 1 by 2 from half to 3 by 2. It is same as less than or equals to, both are same. The third one, that is distribution function, which is important. So for distribution function, we will calculate for each range between 0 to 1, 1 to 0 to 1, 1 to 2, and otherwise as well. So we'll take the upper limit as x and we'll calculate integration function as follows. So this is minus infinity 0. So I know this is 1, but I'll take upper limit as 0. So capital F of x, that is minus infinity to x, f of x dx. By the way, I need to address this one. Capital F of x means it is minus infinity to plus infinity, that is the area under the curve from left. This is x, this is the meaning of capital F of x, that is p of x less than or equals to x, or integral minus infinity to small f of x. This all are same. So I can split into minus infinity to 0 and from 0 to x. So substitute the functions. So this is 0 and this is 0 to x. What is the function here? Cx square. This is cx square. Okay, dx. So c x cube by 3 from 0 to x. 6 by 11, it's 1 by 3 x cube minus 0, that will be 2 by 11 x cube by x cube. This is the first distribution, and similarly same from my, I have 0 1. Now I am taking, instead of 2, I'll take up to x. Okay, here the function is cx square, cx we know that. Similarly, so from minus infinity to x, f of x dx. So minus infinity to 0 f of x dx, from 0 to 1 f of x dx, from 1 to 2 f of x dx. So this is 0, and from 0 to 1, what is the function? Cx square dx. So from 1 to x, cx dx. So c common, 1 by 3 plus x square minus 1 by 2. I'm directly substituted. So what is c? C is 6 by 11 and 3x square minus 11 by minus 1 by 11. So in total, how can we write? Capital F of x, what is distributed? 0. So x is less than 0. From 0 to 1, what we got? This one, 2 by 11 x cube. From 1 to 2, it's our 3x square minus 11, and after 2 it will be 1. So I have some more problems in my handwriting notes. You can refer those problems. Okay, next topic is what I want to say that what is the meaning of this, the real meaning. For example, p of 1 by 2 x less than 3. So which means p of x less than 3 by 2 minus p of x less than or equals to 1 by 2. So we know that this is 3 by 2. P of x less than or equals to 3 by 2 means the area under the curve from the right, that is minus infinity to this area. this is 1 by 2. Same area under the curve from infinity minus infinity to minus 1. So after subtracting these two, we will get this is 1 by 2, this is 3 by 2. This is the area of between 1 by 2 and 3 by 2, or else I can write this, I can write it as capital F of 3 by 2, this is capital F of 1 by 2, and this is uh, capital F of 3 by 2 minus capital F of 1 by 2. Okay. In discrete distribution, we have find 7 different distributions like Poisson, hypergeometric, geometric, binomial, negative binomial, uniform. So in continuous random variable, we will have 3 important probability distributions. The first one is continuous uniform distribution. Continuous uniform. So when I draw a graph between f of x and x, at a I'll get some value. At a plus 1 I'll get same probability, some around so I'll calculate all possible probabilities. When I join this all these points, you'll get a graph. Okay, the area under the curve from a to b is x lies between a and b. Okay, as I told you in the previous class in discrete probability distribution functions, every distribution has 3 important formulas, that is f of x, e of x and v of x. For this, f of x is 1 by range, similar to the discrete, but the only difference is we are not including the lower limit. Okay, so that's why we are eliminating plus 1 here. So e of x is a plus b by 2, same as discrete, and but it is different, variance is different, b minus a square by 12. So examples like uniform, continuous uniform is like it's simple, every time you'll get the same probability value. So that is continuous uh, distribution function, and we'll go into next distribution, that is very important, that normal distribution. So for normal distribution, it is denoted in nu sigma. Nu is mean, sigma is standard deviation, is equals to f of x is equals to 1 by root of 2 pi sigma e power minus x minus nu whole square divided by 2 sigma square. Okay, so x ranges from, and it is a bell shaped curve. When we draw a curve between x and f of x, you will get a curve like this. This is called bell shaped curve, or else it is another name is Gaussian distribution curve. Okay, so it is symmetrical about mean. And okay, here it is very difficult to find a probability functions using normal distribution. So to make integrated free from nu and sigma, like to make integrated free from nu and sigma, I am assuming nu is equals to 0 and sigma equals to 1. So when I put nu equals to 0 and sigma equals to 1, the random variable x will be z. Z is normal distributed variable. So I am introducing new term, that is standard normal distribution. Why we are going to standard normal distribution instead of normal distribution? to make integrated free from nu and sigma, I am assuming nu equals to mean equals to 0 and standard deviation is equals to 1, and by assuming these two values, the random variable x will changes to standard normal distributed variable, so z value. So you'll know the advantages of standard normal distribution in future. So hmm, it's like area under the curve, same, simple. Before it is new, right? So I'm assuming it is 0 now. Okay. One more thing here, when I move forward for one standard deviation, nu plus sigma and nu minus sigma, so I'll write here neatly. This is new, right? So when I go one step forward with one standard distribution, minus, and one step for backward, nu plus sigma, so the range, the values, 68% of the random variables lies between these values. And one more point here, the curve changes its slope from negative to positive. This is the 68% of the area will lies between one standard distribution. So again I'll do another one step forward towards positive and negative side. This area will be 97%. And finally, when I move forward, nu plus minus 3 sigma and nu plus 3 sigma, the area between this value is 99.97%. Okay. It is very important for 6 sigma for industrial engineering. So standard normal distribution, simply it is represents z, and where nu value is 0 and standard deviation is 1, where z is equals to x minus nu by sigma. Okay. It is also uh, symmetric about 0 value. So how can we find out? Z is z of probability of z less than, which means phi of 1.5. From standard normal distribution table we can directly find out 1.5 value, so it's 0.933 from standard table, standard normal distributed table. Okay. For example, same value, if z greater than or equals to 1.5, we can get using negative standard normal distribution table, but we can do like 1 minus p of z less than 1.5. 1 minus phi of 1.5, that is 1 minus 0.93. Okay, this is how we've calculated. So the main uses, you'll know that. Let's do a problem. Normal distribution with the new value is 10 and variance is 4. What is the probability of measurement exceeds 13? Okay, I need sigma, that is the root of 4, that is equals to 2. So just I'm converting normal distribution to standard normal distribution, where z is equals to x minus mu by sigma. Okay, what is x here? 13 minus 10 divided by 2, this is 1.5. He wants to find x less greater than 13. I can 1x, so 1 minus, now I'm changing variables x to z, So instead of 13, I'll change 1.5. Simple. I'm removing x and introducing z value. Removing 13, I'll put 1.5. That's it. So 1 minus 5 of 1 point from table from 1.93, you'll get 0.06668. Okay, same. Let's do a simple problem. P of 9 less than x less than 11. So P of x less than 11 minus P of x less than 9. So z1 equals to x1 minus nu by sigma, z2 equals to x2 minus nu by sigma. What is x1? 11 minus 10 by 2. So z1 equals to 0.5, z2 equals to 9 minus 10 by 2, that is z equals to minus 0.5. So P of I am removing x with replacing with x and introducing z. Z11 is 0.5 minus P of z2 less than minus 0.5. Okay, so I can write phi of 0.5 minus phi of minus 0.5. So from table it's 0.969 minus 0.31, it's around 0.38. That's it. This approach is very simple. Okay, if you need more examples you can find in my handwriting notes. Okay, I think we don't have normal approximation in your examination, but I'm covering here, so I'll not make any video in future. So normal approximation. Normal approximation is simple. The name itself says normal approximated value. Sometimes it is very difficult to find out a value using one different distribution. As I told in the previous class, in third chapter, uh, I can find I can find Poisson distribution like instead of binomial distribution. Originally, it is we should use binomial distribution, but when n is greater than 20 and np is greater than 5, it is very difficult to find out normal distribution. Binomial distribution. So instead of binomial distribution, we will calculated the value into using Poisson distribution. Likewise, we are also calculating binomial distribution instead of normal distribution. So simply it's like originally it is binomial distributed, now I'm using normal distribution. Normal, this is called normal approximation to binomial distribution. We know that z is equals to x minus nu by sigma. Nu value is np in binomial distribution. You remember np q. Replacing z x with z and nu with np and standard deviation with root of np q. So we'll get some error that is called normal error. That error can be replaced with continuity correction. Continuity correction is a corrected value uh, to make equal, like you'll get some error. So to make it nullify, you will introduce a continuity correction factor, simply x less than x, which means I'll take 0.5 extra. So substitute in standard point, x plus 0.5 same n minus np root of np q. This is for less than. For greater than x, I'll simply x minus 0.5. P of z x minus 0.5 minus np by root of np q. This is a normal approximation. You can find more details like normal approximation to Poisson's distribution, So simply it is like instead of NPQ, you will calculate lambda t. This is also lambda t. For Poisson's distribution, you can find more details in my handwriting notes and Dr. Stayari's PPT as well. So let's move into new distribution, that is exponential distribution. Here, exponential distribution is similar to Poisson's distribution. The only difference is in Poisson's distribution, we will calculate for one value, and whereas in exponential distribution, we will calculate between range. So it is the area under the curve from range from A to B. We can see these formulas using Poisson's and exponential in Operation Research 514 subject. So if x is a continuous random variable and it is exponentially distributed, the curve might be this is how it looks like when I draw a curve between x and f of x. So how it is distributed: small f of x lambda e power of minus lambda t. So like Poisson's distribution, we will also have the same uh, keywords like ranges from per and average per are the keywords for exponential distribution. Only difference is we'll calculate range like p of x less than x, okay, whereas in Poisson's distribution it will be p x equals to x, okay. And e of x is nu equals to 1 by lambda, v of x is 1 by lambda square, okay. We'll do a problem. A system can be molded as Poisson's process with a mean of 25 logons per hour. So he has given lambda equals to 25 logons per hour. So the probability that there are no logons in next 6 minutes. So time equals to 0.1 hour, that is 6 minutes he has given. So p of x there, so that is p of 0.1 less than infinity, okay. So from infinity to 0.1, f of x dx. What is what happened? I think no, sorry, it's lower limit is 0.1, upper limit is infinity. So what is the function of f of x? 25 e power of minus 25 x or t, we can use anything. So after integrating this, e power of minus 25 by 25 from 0.1 to infinity. Don't forget upper limit infinity. So 0 minus e power of minus 2.5, that is 0.082. So this is the answer. So using Poisson's distribution, he told that x is equals to 0, that is 0 logons. It's simple, like Poisson's distribution talks about events. It talks about events, whereas it talks about time. Lambda t x. This point is very important in OR subject. Poisson's distribution is event, whereas exponential is about time. So here the event is 0 logons, 25, and it is time is 0. Within time 0.1, 0 e power of divided by 0 factorial, that is e power of minus 2.5, 0.0821. Okay, I think I have covered most of the syllabus in chapter 4. Like if you need more material, you can get from my handwriting notes or from Dr. Stayari's PPT, and try to do homework problems from chapter 4. It will cover everything in exam as well. Thank you so much.